Hello everyone. In this lesson, you're going to learn how to solve and graph two-step inequalities. You're also going to learn how to identify possible solutions. And don't forget, our alligator always eating the bigger number. So let's get to it. Here's the equation. It's a two-step equation. We learned how to solve this two-step equation in our previous unit. Subtract 5 from both sides. We get 3x equals negative 3. Now divide both sides by 3, and we get x is equal to negative 1. Notice that there's only one solution here, which is negative 1. So our answer is x equals negative 1, and we're going to graph this on a number line. So negative 1 is right here. There will be a closed circle right there at negative 1. Which is our solution. Here is an inequality very similar to our equation below. It's 3x plus 5 is greater than 2. So let's follow the same steps for solving this inequality. Subtract 5 from both sides. We have 3x on the left side and negative 3 on the right side. Again, bring the inequality symbol down. So 3x is greater than negative 3. So when we divide both sides by negative 3, we get x is greater than negative 1. That's because negative 3 divided by 3 is negative 1. Let's take a look at how we're going to graph this. So our answer again is x is greater than negative 1. So let's see, here's a 0, here's negative 1, and here's 1. There will be open circle at negative 1 because we want all the answers that are greater than negative 1. So open circle at negative 1 and shading to the right because these numbers are greater than negative 1. That's it. That's how you solve two-step inequalities. Very similar to solving two-step equations. Okay, so we're comparing the equation and the inequality side by side. Equation. Okay, and inequality. Let's go down. So what is this? What are the similarities and differences between solving an equation and solving an inequality? Think about it for a second and come back to this video. So similarities. We solve equations just like we solve inequalities, with one exception, which we will talk about later. And the difference is, notice that equation has only one solution, where in inequalities, you could have multiple solutions. So here, 0 is a solution, 1 is a solution, 2, and so on. So let's go to page 2 and work on example 3. We're first going to solve this inequality, and then we're going to rewrite it if necessary, and then we're going to graph it. And last, we're going to find 3 possible solutions. Okay, so we have A divided by 5 is less than or equal to negative 4. Multiplied by 5, multiply the both sides by 5. So 5 will cancel out with 5. We get 1a, okay? 1a is less than or equal to negative 20. That's our answer. All numbers that are less than or equal to negative 20. We have our variable on the left side, so we don't need to rewrite this. So let's put negative 20 over here. Okay. We want to shade an all number that are less than or equal to negative 20. So that would be closed circle, negative 20, and all number that are less than or equal to negative 20. Okay. So that means one of our solutions could be negative 21. Okay. In fact, negative 20 is also our solution because there's a closed circle. So negative 20, negative 21, and you could pick another number. I'll just put negative 24. So again, there are multiple solutions. Any number that is less than negative 20 is a solution. Example 4, we have m plus 4 is less than or equal to negative 3. To solve this equation, we would simply subtract 4 from both sides. You can separate the two sides by drawing the dotted line. So we have m is less than or equal to negative 7. Again, variable on the left side, we don't need to rewrite this. So our solution is m is less than or equal to negative 7. That means a closed circle at negative 7 because of the equal sign, and all numbers that are less than. So on the left side are the all numbers that are less than negative 7. Okay, so if you want to name a couple of the solutions, anything that is less than or equal to negative 7 is a possible solution. So we can start with negative 7, negative 8, and even negative 100. Even though it's not up there, all numbers that are less than negative 7 are a solution. In example 5, we have another inequality. I have written that down over here. Notice that I color-coded like terms. I'm also going to split the two sides. So here we go. Okay, I have split the sides. 3n minus 2n is 1n. Okay, and then we're going to bring down the negative 1. The inequality symbol facing this way. So 9 is greater than 1n minus 1. Let's solve this inequality by adding 1 to both sides. So I've added 1 to both sides. Keep the inequality symbol same. 9 plus 1, we have 10. 1n on the right side. So 10 is greater than 1n. Basically, n is less than 10. So we should actually rewrite this. Okay, I want to put the n on the left side. So again, notice that 1n and n is the same thing. So n is less than. Notice that I switched the symbol. But technically, it's the same thing. N is less than 10, or 10 is greater than n. So rewriting it makes it, there's no difference rewriting it. Okay, they're both the same. We do want to see the variable on the left side. Now let's graph this. So open circle at 10, and all the numbers that are less than 10 are our solution. Okay, name 3 possible solutions. So well, 10 is not a possible solution. So if we're going to select integers, then 9, 8, and 7 would be 3 possible values. Okay. So in example 6, we have another equation. Okay. Notice that we could actually rewrite the equation at the beginning. So I have x divided by 2 minus 6, which is greater than, okay, it's facing that way, so it's greater than 4. Let's split the sides. Add 6 to both sides. Okay, 4 plus 6, 10. Now multiply both sides by 2. So why are we multiplying by 2? Ask yourself, why are we multiplying by 2? Okay, you're multiplying by 2 because the x is being divided by 2. We're undoing the multiplication. So what we get is x is greater than 20. Here's our graph. X is greater than 20. Okay, I want you to pause the video and think about 3 possible solutions and come back to this video. You could have different answers, but these are my 3 possible solutions. Okay, so now I want you to try these 2 examples. Okay, try them on your own, solve the inequality, rewrite it if you need to, graph it, and then name 3 possible solutions. So pause the video, try the examples, and come back to this. I'm not going to explain, but I will show you the work. Alright, so go ahead, try it. Okay, welcome back. So I hope you have solved your inequalities, and you probably have graphed it, and then you have named 3 possible solutions. Now watch how I did this problem. Okay. Another thing you could do is you can rewrite the inequality at the beginning. It may make your life a little bit easier, okay? Now to name the 3 solutions, I picked -78, -1, 0, because those all numbers are less than 3. And I picked 6, 99, and 500, because those are all numbers that are greater than 5. So now if you feel pretty confident about solving inequalities, I recommend that you try example 7 and example 8 on your own. If you still are sort of confused and you want another example, then go ahead and watch the video. But if you feel like you're pretty good, then pause the video, do these examples on your own, and then come back. Alright? So go ahead, pause the video, try them, and then I will try explaining example 7 and example number 8. This is a two-step inequality, and I have divided it. So I'm subtracting 6 from both sides, and I get 4x is less than or equal to, oops, actually I added the equal to sign for no reason. It's just less than. Alright, I guess I made a mistake, but nothing wrong with that. So 4x is less than -16. Here's our answer. X is less than -4. Here's our graph. I'm going to pick any number that is less than -4 as our answer. So solving this inequality, we get x is greater than or equal to 9. So any number that is 9 or greater is our solution. So 9 could be part of our solution set, 99, and any number that is bigger than 9.